Okay, in this video, we're going to talk about quadratic equations and how to solve quadratic equations by factoring. Well, let's start off with a quadratic equation. A quadratic equation is of the form of ax squared plus bx plus c is equal to 0, where a does not equal 0. Now, what does that mean? Before anything else, that means the degree is 2. Okay. Now, I've given you some examples of quadratic equations. X squared minus 9 equal to 0, and 3x squared minus 5x is equal to 8 are examples of quadratic equations. Now, again, what happens if a is equal to 0? Well, if a is equal to 0, that ax squared term goes away, and you're left with bx plus c is equal to 0. Guys, that is not a quadratic equation. In fact, that is a linear equation that's in slope-intercept form. So that's why it's very important that a cannot equal 0. Now, there are 4 different methods to solve quadratic equations: factoring, the square root property, completing the square, and the quadratic formula. Okay? We will focus on the factoring part of this video. All right. But before we solve by factoring, we need to review the zero product property. And all that's telling me is if I multiply multiple factors together, then one of the factors must be equal to 0. For instance, 0 times 4 is equal to 0. Okay? 0 times 0 is 0. One or both of the factors have to be equal to 0. Okay? All right, so now let's take a look at solving equations by factoring. So we see p cubed minus 8p squared plus 15p is equal to 0. Remember, the very first thing you do when you factor is to factor out the greatest common factor if possible. Notice every single term has a p. So I'm going to factor out or divide out the p. That leaves me with p squared minus 8p plus 15 is equal to 0. Now, let's factor the trinomial inside the parentheses. If you recall, you want to find what? Factors of 15 whose sum is negative 8. Well, that's got to be what? Negative 5 and negative 3, because negative 5 plus negative 3 is negative 8, and negative 5 times a negative 3 is positive 15. So let's factor. Notice the greatest common factor comes along throughout the entire ride. And now I can factor p minus 5 and p minus 3. Every factor that contains a variable must be set equal to 0. So p is equal to 0, p minus 5 equal to 0, and p minus 3. Okay. Now, p equal to 0, you're done. Here, p is equal to 5, and p is equal to 3. So if they ask you for the solution set, doesn't matter the order that you write it. I'll write them from smallest to largest. You have 0, 3, and 5. Now, let's take a look at the next example. We've got 3x squared minus 48 is equal to 0. Again, the very first thing I want to do when I factor is to factor out the greatest common factor. Well, on the left-hand side, that's a 3. When I divide out a 3 from each term, I'm left with x squared minus 16. Now, we know x squared minus 16 is a difference of 2 squares, so I'll factor. Square root of x squared is x. Square root of 16 is 4. Remember, one's positive, the other one's negative. Now, I want to set each factor that contains a variable equal to 0. Now, in case you don't remember that, you can look at 3 equal to 0 and identify very quickly 3 does not equal 0. 3 is not a solution. But I can set x plus 4 equal to 0 and x minus 4 equal to 0. So we know our solutions here are 4 and negative 4. Okay. Again, you write the braces if they're asking for the solution set. One other example I want to take a look at is this. Now, right now, that does not look like a quadratic equation. So there are going to be multiple steps I'm going to have to do even before I can try to solve by factoring. Well, step 1, I should distribute the 8t to both the t and the positive 3. So let's do that first. So I'll write that here as 8t squared plus 24t equals 2t minus 5. Now, notice from the previous problems, I'll scroll up, both of the previous equations I had set equal to 0. So that's what I would like to do here. So I'd like to set this quadratic equation equal to 0. So I'm going to bring the 2t and I'm going to bring over the 5. Okay, so what does that look like? That's 8t. When I subtract 2t from both sides, 24t minus 2t is 22t. And keep in mind, I'm going to add 5 to both sides, so that's plus 5 is equal to 0. Now, again, how I factored in the last video, I'm going to take the constant, multiply by the leading coefficient. So that's going to be what? Factors of 40, whose sum is 22. I'll circle that here. Well, what two numbers multiply to give me 40 and add up to be 22? Well, that's going to be 20 and 2. Because 20 times 2 is 40, and 20 plus 2 is 22. So I'm going to rewrite this, but instead of 22t, I'm going to use the factors of 20 and 2 to rewrite. So 20t plus 2t plus 5. Now, because I have 4 terms on the left-hand side, this is a factor by grouping. So I'm going to factor the first 2 and the last 2. Well, what can I factor from the first 2 terms? Well, 4 and t. That leaves me with 2t plus 5. Now, what can I factor out of 2t and 5? Other than 1, nothing. But the key is I can factor out a 1. I'm going to put a plus 1 and rewrite 2t plus 5. Both terms contain the binomial of 2t plus 5, so I can factor out 2t plus 5 from both as I scroll down a little bit. So, and my other factor is 4t plus 1. Okay. Now, I can set each of these factors that contain a variable equal to 0. So my solutions here are negative 5 halves and negative 1/4. All right, that is the end of this video.